Hello, chemistry students, and welcome to the first lesson in the unit on nomenclature. This is the process of writing chemical names and formulas. To complete this lesson, you should have your notes packet out because we'll be filling that in as we go. And of course, you should have a periodic table handy because we'll be referring to that. Remember that you can pause this video whenever you need to, so feel free to do that to get your materials right now. Are you ready? Let's go. This unit starts out by essentially reviewing what you learned in the previous chapter. In the previous unit, you learned about ionic bonding versus covalent bonding. We will continue to use those words here, but we're also adding another word to the mix. The word we're adding is molecular. The word molecular is usually used to describe a compound. Remember that a compound is two or more elements combined together. The word covalent is usually used to describe just the bond. So if you're talking about an individual bond, you would call it covalent. But if you're talking about the whole substance, the adjective we would use is molecular. When you hear me use the word molecular, you can think of it almost interchangeably with covalent. It means essentially the same thing, just describing the whole compound. Let's start by reviewing what types of elements make up each type of bond. In an ionic bond, you probably remember that the elements combining in an ionic bond are a metal with a nonmetal. In a molecular compound, which is made of a covalent bond, remember, these are all nonmetals. This is a good time to remind you of where metals and nonmetals are found on the periodic table. Nonmetals, remember, are found on the right side of the staircase on the periodic table. The staircase is the divider between the metals and the nonmetals. So in a covalent bond, you have two elements from the right side of the periodic table, and in an ionic bond, you have one from the left and one from the right. The type of bond that we would fill in here should be pretty evident. In an ionic compound, it uses ionic bonds. In a molecular compound, it uses covalent bonds. The final section of this chart sounds a little funny. A representative unit is the smallest piece of that type of substance. For a molecular compound, the smallest piece you can get of water, for example, is a molecule. When we talk about an ionic compound, it gets a little bit trickier. The smallest unit we can refer to there is called a formula unit. This means for salt, NaCl, you would have one Na with one Cl. It's not technically called a molecule because it doesn't have a covalent bond. We'll call it a formula unit, and you can think of it as being very much like a molecule. Next, we'll review what you've already learned about different types of ions. Remember, ions are formed when atoms gain or lose electrons. Cations have positive charges. The reason they have positive charges is because they have lost electrons. You might have learned a fun saying, like cations are positive because cats have paws. On the periodic table, it is metals who are likely to form cations because they have few valence electrons, so it's easy for them to lose electrons. Nonmetals, on the other hand, tend to have a lot of valence electrons, so it's easier for them to gain a few electrons in order to get to a stable octet, 8 valence electrons. For that reason, nonmetals tend to form anions. This distinction is important to remember because we have different rules for naming cations and anions. So again, cations are positive, anions are negative. When we name metals, let's start by talking about the cations. They're easier. When you're naming a cation, you take the name of the metal, and it's actually the same as what you would see on the periodic table. You just add the word ion. For example, the element calcium has the symbol Ca, and when we go to write its ion would be a calcium with a positive 2 charge, and it is called calcium ion. Notice we didn't change the name of the element, we just added the word ion. Strontium would be the same way. It's another metal. It would just be called strontium ion. Notice the charges on there, and we'll talk about where those came from in a minute. When we look at the nonmetals, we have to do a slight change to their names. The nonmetals are going to get a new ending. The ending they get is an IDE ending. What this means for us is that we have to change the ending. For example, chlorine ended in INE previously. To show that it's an ion, we're going to change its ending to IDE. So its name here becomes chloride ion. Notice the chlorine has a -1 charge. Next, when we look at oxygen Oxygen had this -gin ending, and we have to change that ending to an IDE. That looks like oxide. So again, notice the IDE for the nonmetals. Some elements don't form ions, and that's because they're already stable on their own. For example, we know noble gases exist as isolated atoms in nature. Isolated means by themselves, alone. The noble gases, hopefully you remember, are found on the far right-hand edge of the periodic table, and they're stable because they already have 8 valence electrons. They have a full octet. Do you have your periodic table handy? Let's go ahead and look at that and mark where the noble gases are. Noble gases are the group with 8 valence electrons, and they're over here. If you don't have this labeled on your table, maybe you want to do so now. And you make a 0.7. Hydrogen is the point over here. The 7 starts at element number 7, which is nitrogen, and it goes across and down. See how it makes a number 7 here? So this 7, along with the point, is showing you the elements that belong to Brinkelhoff. So if I wanted to label those guys on my periodic table, I might color them in a certain color, and those are my diatomic elements. Finally, let's talk about what we mean when we write a chemical formula. A chemical formula, as you've seen before, is designed to show you the type and number of atoms that are in the smallest representative unit of an element. In other words, the smallest piece you can get of a certain substance that retains the properties of that substance. We can break this into 2 categories. The one that you're more familiar with is probably molecules. Molecules are made of 2 or more atoms held together by covalent bonds. Remember, in a covalent bond, they're sharing electrons, and they're nonmetals. When we talk about ionic substances, they're not technically called molecules. The name for those are formula units, as we saw before. This is made of ions, rather than whole atoms, that are held together by ionic bonds. Let's look at one example of a chemical formula to wrap this up. If we write the symbol for water, water is H2O. Notice that in this formula, there's a number 2 following the hydrogen. The 2 is referring to the hydrogen, meaning there's 2 atoms of hydrogen and 1 atom of oxygen. You'll notice that right here, we don't have to write a number 1 there. It's implied to be there. So you actually don't have to show it, and I'm going to erase it because normally we don't show the 1 on there. This concludes the first lesson. You're now ready to do your practicing on the practice sheet that you have.